Thank you for that very, very kind introduction. Ambassador, President of the Academy, Dr. Zachary, my distinguished colleagues have probably already read my speech because they have touched on virtually every subject I want to discuss with you this morning. As you've just heard from that introduction, I am neither a diplomat and nor these days in distinguished companies such as this do I truly feel a scientist. So to stand before you to discuss science diplomacy is something of a challenge. I want to explore it with you, and I would be fascinated when I've concluded to hear your reactions to what I have to say. So let me start with a simple question. Why am I here? What exactly is science diplomacy? And the best definition we've been able to find of the Royal Society was actually offered by our previous Prime Minister, the Right Honourable Gordon Brown MP, who pointed out what my distinguished colleagues have already said to you this morning, that science is so intimately and centrally and critically involved with the modern world that all the matters which concern governments and the relationships between governments in the language of diplomacy, almost by definition, involves somehow, in some capacity, the world of science and the consequences of the applications of science. These sentiments from our previous Prime Minister were echoed very early in President Barack Obama's presidency, in his words in his address to the National Academy of Sciences shortly after he was elected. And he pointed out that despite the difficult times that the world is currently living through following the recession which began in 2008, the requirements and the necessity for a focus on science to seek the solutions we are all looking for is more, not less, than it was previously. His words at such difficult times could not, of course, have foreseen the awful tragedy we have all witnessed in Japan in recent days. The earthquake, the tsunami that followed the earthquake, and the consequences at Fukushima nuclear power station. I must admit that when I began to think about giving this lecture, I had not anticipated this, and I have changed what I wanted to say because I actually believe these events, as the President of the Academy has already alluded, have changed, perhaps forever, the way in which we view certain aspects of this awful disaster. But one has to say, before I move any further, I would like to express my personal sympathy, which I know is echoed by everybody in this room, for the Japanese people as they go through these difficult and troubled times. So where do we start? At the Royal Society, my colleagues and I also struggled to define what we truly, really mean by science diplomacy. So together with the American Academy for the Advancement of Science, 18 months ago we held a two-day workshop to debate these issues with international groups of scientists and diplomats and other interested parties and policymakers. The best that we could come up with are these three definitions here that I won't read out and detain you. You can see them on screen, but they basically reinforce what I said earlier. It is a reinstatement of science at the center of activities which concern the peoples of all the nations on this planet, and therefore by definition our governments, and therefore by definition our diplomats, informing foreign policy objectives, informing the dialogue between nations which is conducted within the world of science, and using cooperation and using science for the betterment, fundamentally, of mankind. To me, it is simply a return to the situation which, as a young scientist when I was being trained at Cambridge in the 1960s, one almost took for granted. Many of you in this audience today are young diplomats, and you probably wonder what a physicist is going to be saying to you for the next half hour. I don't want to stand here almost as some representative of a high priesthood. I'd like you to feel that we are at one with simply different skill sets, but with a highly advanced state of mutual understanding. That's my objective. So science, to me, penetrates diplomacy at all levels. Traditional diplomacy, what one might call public diplomacy, engaging the public, and that is an important aspect of some of the things I shall say this morning, and what I would term cultural diplomacy. All too often we think of culture as works of art, of music, of literature. To me, one must add science to that list, because truly science is a cultural expression of humanity and what it is to be a human being. Let me, however, address one area where, since humanity became organized in civilized societies and nations, politicians, diplomats, industrialists, and scientists and engineers have fallen into their own company quite easily. I speak, of course, of defense. Defense is often the area of human endeavor where science and technology are so clearly manifest, often with rather awesome consequences, as one has seen recently, for example, in Fukushima, as one has seen in conflicts. I'm not saying any of this because I wish to go any further into this, but one must acknowledge the role of science and engineering as an underpin to the perfectly legitimate activities of both defense industries and the defense of nations around the planet. These, by the way, as you will observe, are both examples of British technology. So I'm not here to embarrass my hosts in the Malaysian government, perhaps myself. That is all I want to say about the issues of defense, although for the future they will continue to intimately involve the very cutting edge of science and technology and engineering. What I really want to talk about, however, is how humanity, how the nations of the world combat what I've called some of the grand challenges that we face. And I'd like to single out two in particular. Food security, feeding the growing population of our planet, and the questions of climate change. Nobody can be other than moved by the plight of many in Africa and other parts of the world. All of us, I think, share, at the very least, a sense of unease as what is happening to the climate on our planet. And all of us feel, perhaps privately, a sense of unease about the nature in which consumption, particularly in such evocative images as this one, and who am I to speak as I flew here on a Malaysian Airlines 747 all the way from London. The things that we take for granted are perhaps the very contributory factors that cause our unease about the changing climate. But let me start with food. One of our eminent scientists of the Royal Society, Sir David Balcombe, who was a Lasker Prize winner some 18 months ago, chaired a report 18 months ago exactly, called Reaping the Benefits, a report oriented towards the science of food production in the context of a growing population on our planet. And all I want to do is to highlight two problems for you here today and throw out a challenge that all of us as members of the human race share. His report, and I know you won't be able to see clearly all of this data, highlighted an issue which all of us should be ultimately both proud of and concerned about. In the bottom right, the graph compares on the vertical axis food production per capita, and on the horizontal axis, the time scale. The graph that is climbing is the Chinese food production per capita. We talk, and indeed my learned colleagues address the issue of the growth of the Chinese economy. We see here that the Chinese production of food per capita has increased by a factor of 2.5 times since 1980. This is a truly staggering achievement. In contrast, at the upper left, which compares the world, Asia, and South America, we see that the African continent in over half a century has not increased its food production per capita. This despite the fact, as Sir David Balcom's report points out, the enormous advances in agribusiness and in the food sciences in the last half century. And his report contains a salutary warning for all of us. And again, I will not read out this quotation. You can access it online on the Royal Society's website. But basically what he is saying is that the science is available to humanity to deploy to ensure that we should no longer have to share the plight of the African peoples in their search for adequate food supplies. We should be able, by the appliance of currently known science, to achieve success in that regime. And he points out that there is a very clear need for policy action. This, ladies and gentlemen, is what science diplomacy is all about. It is about the mutual agreement between nations on policy actions, the basis of which we all agree on, and the basis of which intimately involves science. The other grand challenge that faces all of us, and particularly those of you from the younger generation here today, of course, is climate change. The President of the Academy referred a few minutes ago to Antarctica and the Antarctic Treaty. I had the privilege of being in Antarctica in January this year at the British Antarctic Survey Base in Rothera on the Antarctic Peninsula. And I flew there, unfortunately not in weather as clear as this photograph, across the Wilkins ice shelf coming down from Punta Arenas in southern Chile. This ice shelf mysteriously in 2009, just 18 months ago, broke up overnight without cause, without any understanding so far of what brought this event about. On my way back, I took 2 or 3 days vacation in the Torres del Paine National Park in the southern Andes, and I took this photograph of one of the famous glaciers in that national park, the Glacier Grey. It's 248 square kilometers of ice. But the important statistic is that in the last 20 years, it has receded by 2.2 kilometers. These truly are signs that all of us can see. But the question confronting science, and if I may, as a scientist, indulge myself for no more than 5 minutes, I promise you, on science before I return to diplomacy. The question that you, many of you as non-scientists should ask is, what do we know we know? And where should science admit to uncertainty? I'm just going to show you very rapidly, without going in great detail, some of the things we know we know. On the summit of one of the twin volcanoes on Big Island, on Hawaii, on Mauna Loa, with Mauna Kea opposite, with the astronomical observatory that I've visited many, many times myself, the measurement of carbon dioxide in the atmosphere has been conducted by the US National Oceanographic and Atmospheric Administration since 1960. You can see for yourself, without further comment from me, what has happened. 320 to in excess of 380 parts per million CO2. The reason I went to Antarctica, however, is revealed on the next couple of slides. This is in the zone referred to as the Russian zone, but I am entirely with the Academy President that there should be no zones in Antarctica. It should be a continent which we share for humanity. But Vostok is interesting. Vostok sits on the top of 3.5 kilometers of ice. And the ice cores that are drilled through, which these two scientists are looking at, contain little striations, little stripes, one stripe for every single year. The